Welcome back to The Explainer. I am so incredibly glad you're here today because we are looking at something that is literally changing the game for local AI right now. If you're running open source models on your own hardware, you already love the privacy. You love having total, absolute control. But today we're figuring out how to take those isolated, offline models and turn them into super capable, active assistants using something called the Model Context Protocol. We're going to take that static chat box and basically give it hands to reach out and interact with your digital world.
Because think about this. What if your local AI could actually break out of its sandbox? Standard local LLMs are amazing for privacy, right? Your prompts never leave your machine, but they suffer from a really massive limitation. They're trapped. They're stuck inside a box built entirely out of their own past training data. They don't know the weather today, they can't read the code you're typing right now in your IDE, and they definitely haven't read yesterday's API documentation. That is, unless we actively give them the tools to do it.
So, here is our roadmap for this explainer. First, escaping the AI sandbox. Then we'll get hands-on with setting up Unsloth Studio, followed by adding custom MCP servers. After that, we'll look at the llama.cpp alternative, and finally wrap up with securing your superpowered AI.
All right, let's jump right into Section 1, Escaping the AI Sandbox.
To really understand why this is a massive leap forward, we have to look at the limitations we're dealing with. A standard local LLM is basically a brain in a jar. It's safe, it's offline, but it's completely static, just chatting from memory. But an MCP-connected model, it's totally different. By securely tapping into your local files, grabbing data from your databases, or hitting the web, it goes from a passive chatbot to an active assistant. It's literally the difference between asking someone to guess what's in your filing cabinet versus just handing them the key so they can open it themselves.
And the secret sauce here is the Model Context Protocol, or MCP. It's a framework that securely connects your local models to outside tools. So if that standard LLM is the isolated brain, MCP is what gives it a set of hands, a web browser, and full access to your files. It lets your model take actual action in your real environment, all while keeping things totally private.
Once your AI has those hands, your workflow completely changes. No more vague, outdated answers. An MC-enabled AI can instantly search up-to-the-minute library docs with Context 7. It can use GitHub MCP to map out exactly where your billing code lives. It can run semantic web searches with Exa, drive a web browser to debug UIs with Playwright, or dig into failing build logs on Vercel. You're no longer just chatting, you're directing a highly capable assistant that is plugged directly into your dev stack. Okay, let's make this real. Section 2. Setting up Unsloth Studio.
Unsloth is a fantastically popular way to deploy local models, and they just baked MCP support right into their Studio interface. It's surprisingly easy. Step 1, whether you're on Mac, Windows, or Linux, just run the install command in your terminal. By default, it runs locally on port 8088. Quick tip though, if you want to hit this from your phone or another laptop on your Wi-Fi, run it with the -H 0.0.0.0 flag. Step 2, open your browser to localhost 8088, set a quick password, and you're in. Step 3 is where the fun starts. Right there in the chat toolbar, just click MCP, and boom! Default tools like Exit Web Search and Context 7 are instantly turned on. Sandbox officially opened.
Moving right along to Section 3, Adding Custom MCP Servers.
Now, the default tools are awesome, but the real power is hooking up the specific third-party tools you use every single day. In Unsloth Studio, you just click Add Custom MCP. Give it a friendly name, like Vercel, and drop in the URL. Just be super careful here. You absolutely have to use the server's base endpoint URL, not a random docs page, or it just won't connect. For step 2, you handle the auth. If it's GitHub, you use OAuth. For others, just paste your token right into a custom header. Step 3, hit Test Connection, click Add Server, and make sure you toggle it on. Super intuitive. Let's actually watch a real-world workflow come alive. Imagine you ask your local model, can Unsloth support Quen fine-tuning? Without MCP, the AI probably just guesses or hallucinates based on old data. But with it, the AI realizes it needs fresh information, automatically triggers the ExadaWeb search, and goes out to gather detailed, accurate context from the web.
But we don't stop there. You follow up with search Unsloth docs on how to do this. The model understands the context, realizes a general web search isn't the right tool for specific documentation anymore, and smoothly switches over to the Context 7 MCP. It goes straight to the official library docs and pulls the exact setup steps.
And then for the grand finale, you say, search Hugging Face for Unsloth/Quen models. The AI pivots a third time, calling the Hugging Face MCP server to grab the exact model files available right now. This is the true magic of MCP. It just stacked 3 completely different servers, XOC, Context7, and Hugging Face, in a single fluid conversation, all from a local model running right there on your desk.
To give you a sense of just how big this ecosystem is getting, look at how these tools map to your daily work. GitHub lets the AI read your PRs and issues. Notion feeds it your project roadmaps. Slack lets it search team chats, Vercel gives it access to deployments and logs, and the file system MCP lets the model safely browse your local project files. It genuinely turns your local LLM into a fully integrated team member.
Which brings us to Section 4, the llama.cpp alternative. Now, Unsloth Studio is brilliant if you want a nice graphical interface, but I know a lot of you like staying close to the metal in the command line. For the llama.cpp route, Step 1 is just starting your Llama server with a gguf model. Step 2 is crucial for safety. You create a specific project folder and set up a serverconfig.json file. This creates a hard boundary, a secure file system sandbox, so the AI can only touch the folders you explicitly allow. Finally, you run IBM's MCP-CLI tool. That acts as your terminal host, wiring up your local server to your tools directly in the CLI. It is incredibly fast and super lightweight.
Finally, Section 5, securing your superpowered AI.
Because we are literally giving our AI hands, we really need to make sure those hands only do what we want them to. You definitely don't want your AI accidentally deleting a production database. The golden rule from the official documentation is this: review requested permissions and always keep human confirmation enabled for anything sensitive. If your AI wants to read private data or change a deployment, it needs to ask you for a simple yes or no first. This is especially critical when you mix MCP with web search. A malicious website could have hidden text, a prompt injection, designed to trick your AI into calling a tool without you knowing. Having a human in the loop is absolutely your best defense.
And that brings us full circle. By bringing the Model Context Protocol into tools like Unsloth Studio or llama.cpp, we've successfully broken our local models out of their isolated boxes. We've given them the ability to read code, surf the web, debug builds, and actually assist in our daily workflows, all while keeping local inference completely private. So I'll leave you with this exciting thought. Now that your local LLM actually has hands, what are you going to build first? Thanks so much for hanging out with me for this explainer. Keep exploring, and I'll catch you next time.